Good morning, students. Today we will be studying about how relief is represented in the topographical maps. Relief is the basic component of any topographical map or any physical map. Now, due to modern technology, relief can be calculated with a great deal of accuracy. And we need to identify the ways in which relief is represented in the maps. The term relief is the difference in elevation or height between parts of the Earth's surface, and the height of the land in conjunction with the information about slope and the shape is very useful for many people, including surveyors, geologists, real estate developers, bushwalkers. Geographers use relief maps for understanding the terrain, for physical geography, as well as for understanding the settlement patterns. There are a number of techniques which have been used for representing the relief. So this relief is represented as is said as certain a number which is above mean sea level. The height is measured in feet or meters, and when it is below the sea level it is negative. So in India, the mean sea level of spring tide of Madras is taken as a fixed point to measure the relief. Now, there are different methods which have been employed. So previously qualitative methods were used, and later with the help of quantitative techniques, quantitative methods or more accurate methods have been adopted. Now, the qualitative methods include hachuas, hill shading, layer tinting, and form lines. So hachuas were used in the past before the modern surveying techniques were invented. So these are the small disconnected lines drawn in the direction in which water would naturally flow. That is from the highest slope to the lower slopes. So they are drawn thicker when the slope is steep, and they are slightly far apart. The distance between the hachuas increases when when a gentle slope has to be represented. So if there is a flat area like a top of a plateau, then it can be shown as a blank space or a valley bottom. So there are no hachuas drawn over there. Like for example, here we can see a mountain and we can see the top is flat. Then the hachuas are drawn for a kind of a conical hill. These are also the hachuas for a valley. So these are disconnected lines which are drawn. There's no line which connects them, even if you see a series of such lines. But as the lines are spread far apart, it indicates gentle slope, and the closer the lines are, they represent steeper slopes. So this was used in the early 18th century, and then later hill shading was also adopted, especially for military purposes. So it was a method where a kind of light was cast on the area, and then based on that you could make out where the steep slopes are and where the gentle slopes are. So it is a visually striking method which is ideal for an overall relief pattern. But why is it qualitative? Because still it doesn't represent the exact heights. So it gives information about slope and aspects. So you have to imagine that light is placed uh, at one corner, usually the north west corner, and the steep slopes get illuminated least or minimum, and the slopes which are slightly flat will appear darker. These slopes will appear darker, and the flat areas have slightly lighter shade. So one of this method is where the light is from the northwest corner. So you can see the southeastern slopes which are darker, which can be represented from this diagram also. So a map which is having a hill shading method, you need to see a entire region, and then from that you can make out the various features like the hills, plateaus, valleys, ridges due to the nature of the shading. Then we have layer coloring. This is partly where certain quantitative methods have been introduced, but the shading is done, which is known as tinting. And this is useful for understanding the shape of the land, the nature of the land. And these tints may be based on certain altitudes, which we see in many small scale maps like atlas maps or the wall maps. So the coloring scheme is such that green is used for the lower land, yellow for higher land, and brown for the highest lands. We can see many of these examples when we look at the atlases. But in the topographical maps, you have a different color scheme, so we will talk about that later. Now, the next is form lines. Form lines are just like contours, but in the areas which are marshy or inaccessible, or one cannot go there due to certain other uh, hilly sections or certain obstructions, then they are given as approximate contours. Okay, they do not represent the exact heights, but they are shown in the form of broken lines. So, surveying of inaccessible areas is shown by form lines. So, this is how it is shown, like a dotted line. So, this is not like a hashua, but they are connected lines, and they usually form circles because it is a oval shaped patterns, because it is at the top of a mountain, or it may be a very deep place where beyond this point, inside this area, it is impossible to conduct the survey. So this is represented by a form line. There may be a contour around this of say a value like 100, 200 or 300, or maybe in this case we can say it may be slightly higher, maybe 1500, and beyond that, since surveying is impossible, then the form line is given. Then we have the quantitative methods. So these include spot heights, benchmark, triangulated height, relative heights, and contour lines. So spot heights are the heights which show the exact height of the line at a particular point. That is why we use the term spot height, where in the map a dot is given and a number is written alongside that. So it represents the spot height. So it is the exact height or the precise point which is showing the height above the ground above the mean sea level. It is indicated on the map but not shown on the ground. Then the benchmark is placed on buildings or monuments of a permanent nature, and from this benchmark the heights are calculated. So the benchmark is the height which is taken from this particular level which is fixed, and then the number, it is represented by the letters BM followed by the number giving the height in feet or meters. Then we have a method of surveying called as triangulation survey, where series of triangles are made, and these are the uh, baselines for the survey. So this is a method which is adopted, triangulation and transit survey, and the relief which is done by this survey is represented by a triangle followed by the height. So here we have all the three: the benchmark, the spot height, and the triangulated height. It is also called as a triangulation station because that is the base station for the survey. So this is how they look in the map. Then you have the relative height, which is the difference between the highest and the lowest point, and it is not with reference to the sea level. So if a small r is there, like 12r, that means the relative height is of the feature where the difference between the highest and the lowest point is given. Contour lines are the lines joining places having the same height above sea level. So these lines are very common on topographical maps and they depict the height, the shape and the slope of the landscape. From the shape of the contours we can identify various patterns like a valley, a gorge or a plateau or a mountain pass, waterfall. All these can be identified. Contour interval is the difference in the height between the contour lines. So the contour lines may increase or decrease based on the nature of the land. So a contour line represents the points 50 meters above sea level. Then the next contour line will show the points at 100 meters. The third will be at 150. So in this example, the contour interval is 50 meters. The only disadvantage is that features of insufficient heights, that is height less than contour interval, are shown approximately. They may not be shown accurately. So these are the contour lines. Now we have many